Day 146, Lights and Switches. The purpose of today's lesson is I will learn how basic electrical items such as lights and switches work. Relevance, we use these things every day. Success, I'll be able to describe how three types of bulbs make light and how a light switch works. Today's grades will be homework 146. It's a short assignment of only about, 6-7 problems. And we have a quiz a long time from now on day 152. Incandescent light bulbs. These are the old-fashioned kind. This was the kind that was invented by, Mr. Thomas Edison is credited with inventing these things, but he actually didn't invent the first incandescent light bulb. But he did make the first one that worked well and could be sold profitably. Anyway, we see that inside the glass bulb here we have this wire right there. That wire is called the filament. And these bulbs, the current, it flows into this little tiny silver spot at the bottom, and it goes up through the wire like this, and then it touches the side of the screw mechanism here, and the current goes out to another wire in the socket from that point. If you look carefully at the bottom of a light bulb, you'll see that there is a different color, usually black, that's between that little silver nubbing and the silver sides. That black is an insulator that prevents the current from avoiding the whole light bulb. Okay, so as the current flows through this filament, it makes it really super hot, just like a toaster oven, and it makes it glow. So these bulbs burn out because as electricity flows through it, it gets the wire really hot to glow, and some of the atoms will actually evaporate. And they'll be floating around on the inside there. And when they hit the cool glass, they might deposit. That's why when you have an old light bulb, you'll see that one area or the other is going to be slightly darker. If you have a light bulb in a table lamp, when the light bulb is normally in this position, you'll see the dark spot on the top. That's because the hot evaporated atoms float upwards and hit the cooler glass at the top and deposit, just like dew will make deposits on your car windshield, that kind of a thing. Okay, so we have the atoms evaporating. Eventually the wire will get so thin that it breaks, and then we say that the bulb is burned out. Fluorescent light bulbs. These are either the really long light bulbs in the ceiling of a classroom, or they're the swirly light bulbs that have a tube that looks like this, sort of, and then you have the screw mechanism. Okay, so inside the tube contains mercury gas. Not a lot of it, but some of it, and that's why people recommend that when you break a fluorescent light bulb, that you open the windows to that room and let it air out for about 5 minutes or 15 minutes before you go in and clean it out. Okay, not only is there special mercury gas in the tube, but the glass is coated with what's called phosphor material. There we go, phosphor. And that is a general category of chemicals that will glow and give off visible light when other kinds of light hit it. When electrons jump through this mercury gas, the gas emits ultraviolet light. And this ultraviolet light is absorbed by the coating, this phosphor coating, and that's turned into visible light. So here we have the long tube, like in the ceiling of a classroom. And we have current coming in here, and electrons can jump from this wire all the way through to that wire. And as it flies through, it's going to be hitting all sorts of mercury atoms in this gas. And that causes the electrons of the mercury atoms to jump to a higher orbit. And when the electrons fall back down to their normal orbit, they emit this ultraviolet light. That ultraviolet light hits the atoms of the phosphor coating, and the same thing kind of happens. The electrons of the phosphor coating, the electrons go up to higher orbitals, and when they fall down in a different set of steps, and as they fall each way, they emit visible light. Now, this mercury gas, I better say, is known as a plasma because it has charged particles to it. Okay, next, LEDs. LED stands for light emitting diode. A diode means a material where current can only flow in one direction. So you have to make sure that the LEDs get plugged into the circuit in the right way. Otherwise, they shut off the current. There are two kinds of materials in an LED, and electrons are plentiful in one of the materials, and positive ions are plentiful in the other material. When connected to a circuit, electrons are able to jump from one to the other. They jump from where the electrons are plentiful over to where there's a positive charge because the opposites attract. When electrons jump, they fall to the positive ions and emit light in the form of visible light. You can see here the tiny little gap that electrons will jump through, and that little gap is filled with just normal everyday air, nothing special. So when these break, you don't have to worry about evacuating the room. And there's nothing that's getting super hot here that evaporates and burns out. And so this lasts a very long time, and it does not create much heat. And so that's why LEDs are apparently the wave of the future in terms of how we create light in our rooms. Okay, moving on to switches. The most basic kind of switch is the knife switch, probably the first kind that was invented. And this is the kind that we're going to be using in our labs when it comes to our classroom. And you've seen them in other situations, in old movies and old machines and stuff like that. Okay, so in this position, we have, this is called the knife. And these things here are called the terminals. And the wires are connected to the terminals here and here by little screws. And so when the knife is in this position, there is a gap, and electrons cannot flow from this wire through the knife to that and then to the next wire. They cannot jump across, and so therefore this is in the off position, and we call this an open circuit. When we push the knife down so it touches that terminal, then electrons can flow through this wire, through the screw, through the terminal, to the knife, to the other terminal, to the other screw, and through this other wire here as well. In that situation, we would call it a closed circuit or a closed switch. In a regular old light switch, we still have a piece of metal being moved to a terminal to either make the contact or moving the other way to break it. When you flip the switch up and down, on the inside the plastic is pushing on a spring wire, making it go to one place or the other. When there's no force on the spring wire, the wire here automatically moves over by spring action to touch option A. When you flip the switch downwards like this, then this goes up and pushes this wire to be more in that position, touching this wire. And so by that way you can control where the current flows. In a rocker switch, we can see in the on position here, we'll have a wire going to that terminal, and it can flow up here across the bridge and then down and then out the other wire. But when we have the switch in the off position, current comes in on this wire, comes up to the bridge, but the bridge is no longer connected. It's not touching this other terminal, so the current cannot get to the outward wire. So by rocking this back and forth, we either have this bridge here touching both wires, like over here, or having a break, a space, and so the current stops. Now those are for things that are like on or off, either all the way on or all the way off. But there are some things that are called continuous resistors, variable resistors, continuous dimmers, that kind of a thing, where you could have any amount of current flowing through. And that's done with something where it's diagrammed here. This is where you have a control knob, where as you gradually turn things in one direction, a light turns brighter, or the volume of a musical instrument gets louder and louder. So what happens is that you have a wire connected to this terminal here, and that's where the current is coming in. It comes up to the knob, and this little needle can go back and forth and rub against this dark ring in various places. The current flows into the wire, into here, into the needle, onto the ring, and then it wants to get to the outwards wire. And in this position, the current has to go through that much of the black ring material. And so it has a certain amount of resistance, and only a certain amount of current flows through it. But if we turn the dial and the needle is now over here, then the current coming in goes through the needle and through a longer portion of the resistor. So the whole circuit feels more resistance and less current can flow. And so this turns partially off. It gets a dimmer light bulb. That kind of a thing is happening with a variable resistor or a continuous resistant switch. It has different terms. A light dimmer is another word for it. Okay, and that's the end of the notes.